Okay, viewers, let's start with this oxidation terms first. Okay, let's do it this way. Very simple. Let's try to put it in this perspective in tabular form. This side I'm going to have my oxidation, and here we're going to have a reduction. Okay. Okay, let's start with oxidation here. What is oxidation? I can rightly define oxidation as, this as the gain of oxygen. Okay, as simple as this. I'll give an example. Suppose I have magnesium ribbon, Mg. Okay, and then I react this magnesium ribbon with oxygen. Okay, so what is going to come out here will be Mg. Remember that magnesium, since magnesium is in group 2, its oxidation state in the compound must be +2, and then both of them are going to combine to give me magnesium oxide. Remember that is the formula for magnesium oxide. This must be 0, +2 here, -2 here is already 0, so but you must balance the equation. Whenever a chemical equation is to be balanced, there are two things you must consider, viewers. One is that consider whether that equation obey law of definite proportion, and also consider if the law obeys conservation of mass. In the conservation of mass, the number of moles at this left must be equal to the number of moles here, or their mass must be equal, irrespective that what you have at the left is not the same thing with what you have at the right, but their mass must be conserved. That is the law of conservation of mass. And the law of definite proportion makes sure that this is combining at the right ratio, no, irrespective of the source of the magnesium and oxygen. So that's what we have. So if the equation must be balanced, if it must be balanced, that means 2 should be here, so that this oxygen is connected, is balanced with this one. So, but this is also going to affect this mass, so here 2 goes here as well. But what I'm trying to tell you is not to show you how to balance chemical equation now in this video, but to understand what has happened in this reaction. The oxidation state of all elements in their free states, not combined, is 0. So that also affects magnesium here. 0. Now, what is the oxidation state of magnesium now that it has combined with oxygen? Is no longer going to be 0, but what? +2. But the one which is -2 will be oxygen. Remember that rule number 2. Rule number 2, very important. So -2 +2 is going to give me 0. But in this reaction, there has been an increase of oxidation number of magnesium, which has changed now from 0 to +2. Having gained what? Oxygen substance will definitely oxidize. Take for instance, also we have carbon plus oxygen. Coming over here we have CO2, carbon dioxide. What does happen here? Remember that since carbon is in a free state, its oxidation state is 0. That is rule number 1. And then rule number 2 says that oxidation state of oxygen is -2. So -2 times this 2 is -4. So if this is -4, what is going to be here? And if you add it with -4, everything becomes 0. That should be +4. So there has been a change in oxidation state of carbon from 0 to +4 when it gains oxygen. So whenever an atom of element gains oxygen, its oxidation state will definitely increase in the positive direction. That is oxidation. And then the opposite of oxidation should be reduction. And which is, if we say that this is gain of oxygen, eventually this will be what? Loss of oxygen. So reduction is defined as loss of oxygen. And I would like to give an example immediately on that. If we have something like this, loss hydrogen, and here I have water plus copper. Okay. What do we call this? Remember that you must definitely, in any given substance or equation or any reaction, you must definitely know the oxidation state of one species. Like in this question, CuO, you should be able to know that oxidation state of oxygen is -2. I will know it's -2. So having known it, I already know copper. So if this is -2, definitely copper is going to be +2. So that the sum of everything in the compound should be summing up to be 0. So this is called copper 2 oxide. Copper 2 oxide. That is the name of the copper. Copper 2. Copper is 2. Oxidation state of copper is +2. Though it is not given in the rules, but you can get the oxidation state from that of oxygen, since copper shows variable. There are some compounds of copper that are copper 1. There are some that are copper 2. But as far as this compound is concerned, this is copper 2 oxide. But coming over here, copper has reduced in metallic form, having lost this oxygen to hydrogen. So whenever oxygen is lost or removed from a substance, oxidation state of the substance is going to either decrease in the positive direction or decrease in the negative direction. So copper has changed from +2 to 0, having lost oxygen from that compound. So that is reduction. Okay, we can go to another aspect of oxidation. That is in terms of hydrogen. This first definition is in terms of oxygen. Now let's look at what it is in terms of hydrogen. Now if you look at it in terms of hydrogen, I can also say that oxidation is the loss of hydrogen. Loss of hydrogen. That is oxidation. You can actually define oxidation as the loss of hydrogen. That is, if you are asked to define it in terms of hydrogen, so that means it will not be defined this way, but it will be defined as the loss of hydrogen. I would like to give you an example, viewers. Okay, look at this. Look at this. This is ammonia. Ammonia can eventually decompose into this and this, where it was formed through Haber process. Okay, so in this case, trying to balance equation, I think that's what I have here. Okay, now the oxidation state of nitrogen here is -3. How do I know it's -3? There is no rule for nitrogen to be -3, but I know there is a rule for hydrogen, which is either +1 or -1. So, but as far as nitrogen and hydrogen is concerned, since nitrogen is a non-metal, oxidation state of hydrogen must be in a positive direction. So it's not going to be -1, but +1. So if you have +1 times 3, that is +3. So +3 minus 3 should be giving me 0. So hydrogen here is +1. This is definitely going to be -3. So what is nitrogen here? Of course, since it is neutral in this molecular state, nitrogen is 0. So there has been a decrease in the oxidation state. Sorry, an increase rather. Something has changed from -3 to 0. This is oxidation. You may be surprised. Pause the video. Nitrogen has changed in ammonia from -3 to 0 when it is alone as a molecule. This is oxidation. Change from -3 to 0. That is increase in the oxidation state of that substance. Then if you go to the other side, I can define reduction will be opposite of this one. So if this is loss of hydrogen, then reduction will be gain of hydrogen. I would like to use this example, but I will use it in the other way around. So I'm going to have N2 plus H2, you'll have NH3. Try to balance this equation. I think I have this balance. So I'm interested only in nitrogen here. This is 0, of course, you know that is rule number 1. Go to that rule number 1 again. You can rewind the video and see what the rule say. And if you're coming over here, this is going to be what? -3. So having gained hydrogen, nitrogen here has formed an ammonia, and then it has reduced. Its oxidation state has decreased from 0 to -3. This is a clear case of reduction. And then, we can also define oxidation in terms of transfer of electron. In terms of transfer of electron, I can see that oxidation is the loss of electron. Oxidation is the loss of electron. And the opposite of loss of electron in this case, that means reduction will now what? Gain of electron. Loss of electron, and then here is gain of electron. How is it loss of electron? There is gain of electron. One may think, since it's oxidation, it should be gain of electron, it's oxidized, and since it is a reduction, it should be no. Why oxidation is the loss of electron is because suppose we have a sodium atom whose oxidation state is just 0. Okay? with number of proton. Number of proton here is 11. Remember, once a species, once an atom is electrically neutral, the sum of proton is equal to this number of electrons. So it's 11, 11. Okay, I suppose, so let's use this dot as the valence, the last atomic shell electron of sodium. Remember, the electronic configuration is 2, 8, 1. So I'm interested in the last subshell, where it only has just one electron there. Okay, supposing it goes on and on and on and on to lose that electron. Supposing it has lost that electron, so we are going to have Na with no dot again. That means it has been lost. So that is this case. That means we're going to be left with only 2 8s in this case. Now we're going to have more proton than electron, because proton is still in the nucleus, so it was not removed. What was removed from the shell was the electron. So that means electron will decrease by 1. 10 electron. That is when it has lost electron. So whenever a species has more proton than electron, once there are more proton than electron, the substance becomes more of positively charged. Positively charged. So having lost this 1 electron here, oxidation state of sodium has increased from 0 to +1. And then if you come to the other side where it has been gain of electron, supposing I have chlorine. Chlorine can gain whose here is 0, so proton here is 17, electron here is also 17. So having gained this electron here, having gained an electron here, so what has happened here? So here we have chlorine, where proton still remains 17, so gain of 1 electron will increase electron to be 18. So once you have more electron than proton, remember electron is negative, the charge, proton is positive. So when it's more electron than proton, the shell becomes somehow negatively what? Charged. So there has been a change from 0 to -1. So that means there has been a case of decrease in the oxidation states of chlorine from 0 to -1, having gain in electron. So gain of electron is reduction, loss of electron is oxidation. Very important, you know that. Of course, these particular aspects of redox reaction is more, I don't know how to put it. If I'm asked to define oxidation and reduction without being specific, examining being specify which of the definitions you are using, I'm going to take this. This is the most preferred definition of oxidation and reduction. Because in any way you have it as gain of electron, gain of oxygen, loss of oxygen, or gain of hydrogen, whichever way you have it, in that case of the lose and gain of oxygen or hydrogen, there is transfer of electron. So generally speaking, the general definition of oxidation and reduction has to be that of transfer of electron. That is to say, oxidation is the loss, reduction is the gain. Always remember this. Remember, you must try to remember this definition. You have oil, rig. It's very simple in the definition. Don't forget it's oil rig. What is oil rig? It means that oxidation is loss of electron. Oxidation is loss of electron. Always bear it in mind. Reduction is gain of electron. Oil rig means oxidation is loss of electron. Reduction is gain of electron. Please take note of this. Oil rig. There is one more definition I'm going to also give you, but that one should also be very, very important. You already know that. So I'm going to summarize 1, 2, 3 in this last definition, where I will now say that oxidation is the increase of oxidation number of a substance. So what will be here? Reduction will be now what? Decrease. Decrease of oxidation number of a substance. Okay, and then I would like to add one more definition, so I can be having 5. Very important. Okay, I don't want to play this, so please take note. Reduction, gain of oxygen, loss of oxygen, loss of hydrogen, oxidation, gain of hydrogen, reduction, loss of electron, oxidation, gain of electron, reduction. Remember this one, in this block form. where I use oil rig. Oil. O, oxidation is loss, reduction is gain. Increase in oxidation states, decrease in the oxidation state. I'll add more of the definitions of this. Supposing it has to do with electronegativity this time. What if it has to do with electronegativity this time? I will already say that oxidation is the gain. Gain. I say it is the gain of electronegative elements. So that means the opposite will be what? Loss or electronegative element. Okay, what is this? This is Fe, ion. Suppose I have sulfur here. Sulfur is an electronegative element here. It's more electronegative than ion. So what is going to come out here is what? FeS. What you have here is ion 2. Ion 2. Ion is plus 2. Here is what? Minus 2. Both are what? 0. So ion here has changed from 0. It's changed from 0 here to plus 2. This is oxidation. So that means it gains sulfur, it gets oxidized. So if it gains sulfur, which is an electronegative element, it gets oxidized. And then sulfur, when gains this electropositive element, what happens to sulfur? Sulfur gets what? Reduced. Okay, so this one is what? Reduction. That means sulfur has changed from 0 here to minus 2, having gained electropositive element. Or sulfur having gained, but ion having gained electronegative element, it got what? Oxidized. So if I try to remove sulfur, separate sulfur from ion 2 sulfide, I'm going to have Fe plus S. 0, 0. Here is minus 2. Here is plus 2. So if I remove an electronegative element, that means that is loss of this S from FeS. Ion is going to reduce from plus 2 to 0. This is reduction. Okay, so having removed electropositive element, sulfur will increase from minus 2 to 0, and which is oxidation. These are definitions. I think I gave you up to 5 or 6 definitions of reduction and oxidation, but take notes. Make sure the definitions of number 3, 1, 2, 3, this one that has to do with transfer of electron is all inclusive as far as definitions of reduction, oxidation is concerned. I would like to take you to the last objective of this lecture, which is oxidizing and reducing agents.